Okay, yours truly, Dolphy Alexander Gilpin. Return to the Radisson at the Tennessee's International Airport. About 5 minutes or 3 minutes, 4 minutes right away from the Tennessee's International Airport. We call it BNA. And we have returned with our amazing 5x12 matrix in the electrical electronics configuration. And we're doing some circuit analysis, some circuit designs, some RLC circuits. The last time we just had resistance and voltage and current, which resistance is the basic element, but now we have some inductance and some capacitance, and we call them RLC. And sometimes we just have RLC, which is resistance and capacitance, RC circuit, or sometimes the RL circuits, resistance and inductance, and sometimes all three. But anyhow, let's go. So we're going to take ABC operator again, and we're going to do the first and the last. And we're going to miss out a whole bunch, about 16. 1, 2, 3, 4, multiplied by 4. 16 of these we're going to be missing out and doing the first and the last, which is this. So this is the first and this is the last. If we take it coming down the column, going so. All right, so let's say now ABC, depending here now, A, B, C operator, and into now R21, R22, R21, R22. This is how we do the getting some 3x3 there now. So ABC R21, R22. And we get now R33, inductance 3, inductance 3, 4, capacitance 3, 5, capacitance 3, 6, and resistance 3, 7, and resistance 3, 8. Continue to get now inductance 4, 3, inductance 4, 3, inductance 4, 4, capacitance 4, 5, capacitance 4, 6, and resistance 4, 7, resistance 4, 8. For the last now we have inductance 5, 3, inductance 5, 3, inductance 5, 4, capacitance 5, 5, capacitance 5, 6, and resistance 5, 7, resistance 5, 8. And so here we have, using ABC, that a 3x3, if we just use what's inside the elements inside the matrix, and we're once again using paired. So we'll be taking that together, and that together, working in paired matrices now. That's how we get 3x3. Otherwise, it would be 1, 2, 3, 4, 5, 6, a 6 by 1, 2, 3. If we didn't work in pairs, it would be 6x3. But we work in pairs, it becomes a 3x3. And similar, we'll have to do all of these, but we do in the first and the last. ABC, and so that's that. So let's do the last. So we have now ABC. The last would be R27, R28, R27, R28, and there we have our 3x3 paired again. Let's try to squeeze it in here. And so if we ABC R27, R28, we'll be left with now R31, R32, R31, R32, L33, L, inductance 33, inductance 34, and capacitance 35, capacitance 35, and capacitance 36. We're left with here now resistance 41, resistance 4.1, resistance 4.2, inductance 4.3, inductance 4.4, and capacitance 4.5, and capacitance 4.6. Come back here. We have resistance 5.1, resistance 5.2, resistance 5.1, resistance 5.2, inductance 5.3, inductance 5.4, and capacitance 5.5, and capacitance 5.6. So here we have inside here now a 3x3 once again, one, working in pairs. This time let's just take it, the pairs going down the column. And across here will be column and coming down with the rows. So we're working in pairs. I don't want to mark up all the thing and make a mess. So we do the first and the last, and likewise we'll do the first and the last of this one, which would be this and this. So all these others have to be done in the same way, but we're making some abridgment here. That's how we're going to get exponential amount of matrices as well. 2x2s, 3x3s, and well, the 4x4s we'll only have about 5 of them. 1, 2, 3, 4, 5. The 3x3 will have about 16 of them, and the 2x2s will have a whole bunch of them. All right. All right, if we could just squeeze in for this 3x3, we'll sort of get some circuits. Let me just draw it looking like so. Some RLC. This will be like resistance. We're going to have some inductance, and capacitance. And get another one. This is for example of some 3x3s here now. Resistance, inductance, and resistance, inductance, capacitance. RLC. Let's put another voltage source there. And could fling in another voltage source here. That's right. So what we've done, we have some circuits like so. 3x3. For this one, we'll have some 4x4, probably looking like so. Resistance, inductance, and capacitance. So this would be 1, 2, 3, 4. Something like that for the 4x4s. This will be the 3x3 circuit that we'll have to solve. But now the thing is that we'll have to put in the elements. The elements of these now will give you the magnitude of the resistances and the inductance. And for these, we'll have some small numbers. We'll arrange that the elements have some very small numbers so that we could solve for them very easily. But for this, we're going to make reference to other forecasts or broadcasts of these circuit analysis problem elsewhere in my advertisement of these circuit analysis solutions and circuit design by the 3x3, the 2x2s, and 4x4s. So we're going to take a break, and when we come back, we'll do the MNO, this and this, and then we'll move on to some 2x2s, and similarly some 2x2 circuit to be solved. Like I said, the elements would be these, which is in algebraic form at the moment, or unknown quantities. We'll have to put in the elements, and we'll use them and dual number. If we have 1, or 0.1, then we'll have 0, 1. Well, when we use decimal point, the 0 becomes significant. But if we have whole number, then 0, 1 is 1. But for decimals, 0.01 is different from 0.1. Well, you know that. So let's take a break here and return to our circuit analysis. And that on the side.